Okay, so this is a flip video that demonstrates how to determine the limiting reactant. This is going to be the first video in a series, so you might want to go ahead and copy down the reaction. And of course, this video assumes that you can write this reaction from words. This is actually a lot like your lab, where you took the copper sulfate, you added iron, and then a single replacement reaction happened where you got copper in solid form and then an iron sulfate solution. This is actually iron 3 sulfate. We used iron 2 sulfate, but I'm sure you get the idea. And the general setup of a limiting reactant problem basically means you're going to have grams or moles of reactant given, and you need to find out which one is going to limit the amount of product that you get. So these numbers have to be given. Sometimes they're given in moles. Today we're actually going to do the difficult one when they're given in grams. And then you have to be sure which product you're asking for. And in this case, we're going to go ahead and ask for the copper just because it's a little easier in terms of using grams per mole. So let's go ahead and get started. Doesn't really erase all that well. Hang on. There we go. Ah, that's better. Okay, so the first thing we need to do is find out how many moles of copper that this copper sulfate is going to make, and then how many moles of iron that, how many moles of copper the iron is going to make. And so, in order to do that, this is just a simple stoichiometry that we've done 1,000 times. We're going to start with 4.17 grams of copper sulfate. And then what we're going to do is we're going to go from grams of copper sulfate to moles. And in order to do that, we need to find the molar mass. We've done this before, as a matter of fact, in an earlier flip video. I went ahead and found it out using the periodic table, and this is what I got. And remember, it's always important to write 1 mole of copper sulfate. If you remember in one of the earlier flips, we talk about it sort of like saying teaspoon of baking soda, cup of sugar, that type of thing. So once you get to the moles of copper sulfate, then you need to use the mole ratio here to determine how much copper you're going to get. So then you have 3 moles of copper sulfate. Gives you 3 moles of copper. And when you do the math here, and I probably should have crunched it over just a little bit more, when you plunge all of this into your calculator, you're going to get 0.0261 moles of copper. And we need to remember this number. As a matter of fact, this is definitely a number that you're going to copy down, because you'll see in just a second, and I hate to spoil the surprise, but this is the limiting reactant. Okay. So now what we need to do is take our grams of iron and find out how many moles of copper we're going to make. So in this case, we're going to start with 7.54 grams of iron. And we're going to find the mole, or actually this is the atomic mass from the periodic table. Alright, grams of iron, 1 mole of iron. And then what we're going to do, oh, hold on. No, I'm right. I'm good. Okay, sorry. Now what we're going to do is we're going to do the same thing with the mole ratio here. And in this case, right, we've got 2 moles of iron. And that gives us 3 moles of copper. And these are the coefficients we use, the mole ratio. And when we do the math, through the magic of math, we get this, 0.0203 moles of copper. So now, in order to determine which one is the limiting reactant, we look at these numbers and figure out which one is smaller. This one is definitely smaller by about 10. So it turns out that copper sulfate is going to be the limiting reactant.